So yeah, go back to this. And
Is it recording voice too, or just only screen?
I believe it's also recording the voice. So yeah, so then as I was saying, let's see. Sorry, where am I? Okay, so once you have this launch file, so the way to launch this launch file is go back to the command line. So just go into that folder, cd document software 2020. Sorry, this is the my root folder, but for you, you only have the project workspace. So after you unzip your file and then go into just like that zip folder, and then doing a cat key make source dev setup.bash ROS launch, what's it called? Project gazebo turtlebot playground, and then you might see this error, which is like what we saw at the beginning when we played with the turtlebot 3 example. You need to do the export turtlebot 3 model equal to waffle pie. Waffle pie is the one we are using. And then launch this command. And if you forget like what I need to be typing, you just go Google and then search for turtlebot 3 email. This is where everything begins, and this is where everything you're going to, wherever the question you have, you're going to answer you. So before I move on, so here is the, I'm not sure if you guys still remember this, but this is the example we did during the class. But for this project, I basically just copy paste this launch file into our own custom workspace and then add a code key into it. So everything else is going to be like the command you're going to launch is going to be exactly the same as the turtlebot 3 email. The only difference is this simulation work because we're using our own custom one. So this is only command going to be different. Besides this command here, everything else is you can just follow the email. So once you launch that, then you will see a gazebo showing up like this. And then so for the IMU controlling, I'm not going to talk too much. I mean, you guys already do it before. So just like touch IMU, doing the controlling, move the robot, just like driving around. So besides that, now let's talk about the map creation, which is the part we're going to show on the project. So you go into the turtlebot 3 menu, the slam and tab. Go to the first one, run slam node, and then let's select our version, which is the Notix. And it's not my phone. Okay, so let's scroll down. So from here, let's scroll down to the here. So yeah. Okay, so just pay close attention to the next 15 minutes because all this is a new concept and we probably don't have time to ask you guys to try during the class. So I'm just going to run through everything and then you guys just see what I do. So for the 4 point, that's left. 4.1, under the third point. This guy, the slam, is the command we'll use to creating a map. And then for this, is using the burger, but we're not using burger, we're using the waffle pie. So just remember to change this guy to waffle pie. And then launch this guy. So let me do it here. Control C. Okay. So export this equal to waffle pie How to spell waffle pie? Let me see. What do they have here? Okay. Equal to waffle pie, and then go back to this, and then launch the filibuster stem. And it tells me I don't have a package. Let me install this one. So after you launch the SLAM, you will see something like this. So this is basically the beginning of the map creation. So this is the gazebo of how it looks like. Let me put this guy on the left side. This guy go to the right side. And then let me just keep these two. So next, let me just launch the command in here to drive the low bar around, which is this one. See here. Waffle pie, and then launch the keyboard here. So out here, as you can see, as I like using the keyboard command to move the low bar around, this map is being filling up as the low bar is moving. So in here, I'm using the keyboard command to control the turtle bar, which is like what we do for the beginning of class. But for you guys to create this map, don't use the keyboard, use the IMU stuff you make. So using that to just like drive the low bar around to finish the entire map. Okay. So let me just like drive a little bit more so I can have a little bit more map to do the navigation. So this one, go. Okay, that should be enough. So after you have the map, and then you're going to, so for me, I haven't finished the entire map, but for you guys, for the homework, you guys need to drive through this entire house, every corner of that house, and then just like fill up the entire map. So after you finish driving, then you need to save the map in order to use for the navigation. So the command to save the map is if you guys scroll down to the bottom, on the here 1.4 save map. This is the command we need. So you guys.
Did you record the screen or?
Oh yeah, I did record screen. Yeah.
Sure.
So once you guys have the map, then you need to save it, which is this guy, and then let me open this. Go here, open a new tab. So for this command here, let me put this on top so you guys can see it. So for this command here, so restaurant map saver is a package. This is a file name, the script name, and then this is just like the command you need to use -f. And here is the path of where the map is going to be stored at. So for me, I can just use the default location, but if you guys want to use the default location, then just change this. Basically, until here is the format you have to type to save the map. And then this is the location, like where you want to save it. You can just change to whatever location you want. So after that, if I click on the save, so you go back here, and then you give me a bunch of error. Let me just ignore. Now you can see under my home folder, I have this map here. It's been generated by the command I typed in earlier. So this is a map just created by the others at this time. So this is as far as like the map creation goes. This is the first part of the project during the spring break. So launch those two commands while doing a recording video using IMU to drive. And then, yeah, that's the first part.
Okay.
Yeah. The second part of the homework, which is the navigation. So go to the tab file. And then the 5.1. So in here, because we are running the simulation, so we are going to ignore the first two. This is for the physical robot. So let's just go to the third one, the third point. And then still the same, we are not using burger, we're using the waffle pipe. So remember to change the model to the waffle pipe. And then launch this particular command here. And then for this command, one thing to notice is here, this is the path to where the map is going to be located. So by default earlier we store under the home folder, so which is it says home folder and then map. But if you put it on a different place, then just change this location to wherever the location you are storing your map. Okay. So this is the command for running navigation, and this is where the map is being located. So here's the part. In order to run the navigation, you need to kill the slam, which is the map creation. Because these two will conflict with each other. One is using the existing map you create. The other one is before, like you run the navigation, you create a map. So let's kill the map creation like the command, but keep the simulation running here. So we have the simulation still running. And then we're going to copy the navigation, which is this guy, to here. And then after you paste in the navigation, you can see at the beginning, this robot has no idea where he is. So it's just like somewhere here, but it's actually supposed to be somewhere out here. By at the beginning of the navigation. Hold on. So actually, let me kill everything and start from the beginning, because the robot right now, the initial position is a big difference. That caused some confusion. Let me see. So after the map creation, yeah, actually just to be like make it like easy and clear. That's after the map creation, stop the video recording, kill everything, and then start over. So the second one is I just launch the simulation, and then after launch the simulation, you launch the navigation command, which is this guy. So launch the navigation, and you should see this. So now we're back to what I was saying before. So by default, at the beginning, you can see our robot is actually here, which is right next to our table. In terms of map, it should be somewhere here. But for the navigation, like once you're loading up the map, you haven't given the initial position of the robot, which means the robot has no idea where it should be and which location it should be. So that's why when you load the map, it's just like just somewhere randomly on the map. That's why as a user, as an operator, we need to give the initial position of the robot to let the robot know where he is. So the way to do that is if you guys look at these two, the average two on the top here, it has a 2D pose estimate. You click on this button here to give initial pose of the robot. So if I click on this, and I click on the map, so this is like where the robot is, and then the rotation of the robot. So you just like click on here, and then rotation is facing front. And then here I have the second button, which is the 2D navigation goal, which defines where you want the robot to go. So for me, so let's see if I want the robot to go from here to here, and then maybe face this direction. Okay, so once I define the navigation goal, and this guy should be moving. Let me see. Oh, because I am missing a package. Give me 1 second. Let me install a package. Sudo apt. So I don't believe you guys have this will have this error because you guys should have installed a package. But if you do have this error, so like that one saying the DWA planner ROS package is missing. So then what you guys need to do is doing a sudo apt install ROS nanotics DWA planner local planner and then install. After that, let's go back to launch the navigation. No error. Okay, cool. So, which means going to first doing the initial position, which is here. Going to do the navigation. Let me try to go here. So once you're doing that, then you can see this low bar here. The red line is the path planning. It's like trying to follow this path and then go to here. And then so this is location of the final destination. So this is the second part of the project. Doing a recording of launch the simulation and this guy running, and then move the low bar like doing the initial position, doing the goal position, move from point A to point B. So that's the second part of the project. Okay. So this is just I also just launch the command to get you guys to familiar how to play with them.
Okay. Both parts are due by Spring Break.
Yeah, so actually all like it's going to be a 4 part, but 4 parts is like one project. Yeah, so this is the second part. Yeah.
The 4 parts are going to be due next for Spring Break.
Yeah, I mean, so this is just running the command. So this is you don't even need to run any code.
Okay.
Yeah, this is just like a recording video. Same as the first one, just a recording video, and then use the homework you guys do earlier.
Unless there's no error. Maybe some package error you have to fix.
So after this one, the third part was see. Actually, yes, the third part is actually already combined with the first part, which is using the IMU to drive the low bar through the entire space to create a map. So the last part will be the image detection, which we already talked about earlier. So just using the source code cipath, and then to navigate through the space based on the destination and the position of the code.
Initially, that instead of since we didn't give as training set and object detection, we make a simple red color board. So it's using OpenCV already we did in color detection, right? And in the simulation model, we just make a slight changing because we didn't have chance to make training set yet. Right?
Sure. Okay.
And actually, the project one's goal is making a training set and finding that a training set what the object will detect. Then based on that, and we have to go there. But since we don't have any training set yet made, so but we already completed of the color detection, right, of that image. So we may add some specific colors of the ball you creating and put in the gazebo, and just detect the ball. Then using simple color detection algorithm, you can figure out where is the ball is. That is simple, but idea is same. Instead of the color detection code, later on we make a training set and just replace the color detection to machine learning data.
I suppose the trains that need to do it on the computer, right?
You can be at home, you can do PC, but training set is I don't know. Making environment also one of challenge, but I try it at home. But because there is a instructions, you can set up the yellow package in your PC.
Okay.
You can do it.
So my humble 2060 up to the task.
So I guess like the for the project, like the basic one is using the last part is using color detection. But if you guys are able to do the training set, which you get like an additional point. If not, yeah. Okay, so yeah, so I mean it's going to be the same environment. Since this code is actually the red color is kind of hard to see because of the light, but this is actually the red. So you guys can just do the color detection. If you guys are having hard time to doing the training and all that stuff. So just doing basic color detection on this Coke can, and then doing the navigation. If you guys able to figure out the training set and then using the advanced algorithm like the Cypher introduced earlier, then there will be additional point. But yeah, so this is that. Questions?
So like that color detection, that's part of assignment 6?
Yeah.
Okay.
So basically, like you're going to be combining assignment 6, assignment 5, and then a bunch of command I just showed earlier, so into one big project. So there's not much like a new programming per se. It's more like just reuse whatever you guys did before, but more merge of them into one.
Okay.
Yeah.
But the homework 4 is the one due in spring break, right? 5 and 6 are due too on spring break again.
I think 5 is due on the 27th. That you
Oh yeah, it's 5. Yeah, sorry. I was confused. Sorry.
So the goal of the thing is that
I get it now. Yeah.
you guys can able to do it, and in general, the robot can understand where I am, and also in time I can build a map. Even also whatever I'm going to use, later on we improve if we have some more advanced theory, and understanding that detecting some by target, and simple color detection, basic recognition, and object detection, every training set, behavior model you build, and then do something motions and you can trigger. The all combination have to be dealt with robot have to handle the environment. So that's the starting point, and after that, implementing the robot, and assemble, try, see the errors, correction of. That is the way.
Good.
Also, I see the class is over, but before we go, any questions you guys have for the assignment 5 and 6? Because that's the baseline for the project. So if you guys have any question, I can answer those questions right now.
Many, but later on.
Okay, sure.
I need to start working on it.
Alright, so yeah, that's that.
Thank you. Is it over?
Yeah. You have
Start
anything?
I think it's still recording.
Yeah.